This is Godot, the greatest open source game engine with its own Python-like language. And this is Backgammon, the oldest board game being first introduced in 17th century England to survive the millennium, and it's time that I made it in 7 days. Now, let's travel back to a bit over a week ago when I first needed to pick a game engine. Or not. You see, a game as simple as Backgammon could probably be built with a GUI or web framework. However, if you're me and you want to appease the gaming gods, you'd want to use one of their own tools, the Godot game engine. Mainly because I vowed to never start another project in Unity after an unfortunate series of events that befell the community. Next up, it's language time. Godot has a lot of possible languages, from official ones like C#, C++, and GDScript to community-supported ones like Visual Scripting, Rust, and Lua. For the sake of simplicity, I'll be using the Python knockoff that goes by the name of GDScript. It's simple, it's intuitive, and it's, well, fast enough. Now, no game is truly complete without rules and regulations, and Backgammon is no exception, with a few simple rules that ensure the game is fair. Let me just list a few of the most important ones I'll be following for today's video. Firstly, Backgammon is to be played with 2 die. If both die land on the same number, the player will be able to move 4 times. Next, if the player's piece lands on a singular opponent's piece, then the opponent's piece will be moved to the center to restart from the beginning. However, if there are no moves available for that centerpiece, then the opponent's turn must be skipped. Furthermore, if all of the player's pieces are within the last 6 triangles, then they can start storing their pieces. If all of said player's pieces are stored before their opponents, then they win the game. With these set simple rules, we could begin creating Backgammon. So I opened up a new project in my favorite game engine and began working on the structure of the project, like whether the board game would be in the 2D game layer of Godot or its UI layer. Heads up, I picked the UI layer because it's so much easier to scale for multiple sizes of screens. After that decision, I began creating the board game of my dreams. And some early assets, like the triangles, aren't they just so pretty? I mean prickly and menacing. Then out of nowhere, a challenge appeared. How was I going to space out the pieces on my board when they were on the spikes, only using Godot's built-in tools? At first, I thought I would get the size of the piece and add spacing before placing the next piece in that pre-calculated position. However, issues arose, like how to deal with when the screen changes sizes, like when someone resizes the game window. And because these calculations only done whenever a new piece was added, it made it almost a too difficult route to go through. So instead, I settled by relying on the beauty that is the Godot game engine a bit more heavily. You see, by having each piece be a basic control node and then locking the size of the piece's image to be the width of said control node, we can achieve a perfect uniform scaling without touching a grain of code. To finish off that first day, I added some functionality to add said pieces to the triangles and added some placeholder assets to represent the piece stores, and then I went to sleep. Day 2 was all about getting that MVP, minimum viable product, by finishing up the basic game loop of adding pieces, rolling die, and moving pieces. Isn't it just so creative, innovative really? Such a complex game, isn't it? These 3 core functionalities will be the key to the success of this game, and the most important things not to mess up. Luckily, I could never mess up. This isn't foreshadowing, by the way, I just never messed up these parts. So, it made it even better when one of Godot's key selling points came into play. My favorite part, besides the rest of the engine, signals. By basically having each spike, triangle, act as a button and relay the player pressing it to the monolithic game manager script to handle. By having this functionality, I could easily separate functionality that needed to be handled game-wide and that functionality that only needed to be handled by each singular triangle. Day 3 was a bit busier than usual. As my notes keep reminding me, I basically did nothing except work on polishing the game to make it just that extra bit smoother and, well, less buggier. I also worked on a buggy implementation of the mechanic of moving an opponent's piece to the center before finishing the day feeling as if I had done basically nothing. Thanks, outside life. Day 4 was crucial because I needed to make up for the lost time from day 3. The beginning of, say, day 4 was spent making a couple quality of life improvements, such as adding visible die, because it was kind of becoming difficult troubleshooting functionality when, basic things like the die and the roll that you got was locked behind a console output. That, to make matters worse, could be very confusing and difficult to understand. For the die themselves, I just made 6 basic textures that represent all their possible numbers. Whenever a dice was selected, it would just change the texture of a preloaded dice prefab that I had created, therefore communicating to the player what roll they can do. After that, because I was clearly on a theming roll, I decided to style the game to be in the cat puchin theme that I use on my computer, everywhere, because I'm not obsessed with it, I swear. Or at least, that's what I told my therapist, who told me that obsessing over uniformity was just a sign of how special I was. On day 5, I finally realized that my rushed and spiraling spaghetti coding was leaving me with a lot of debt, technical debt, that was making it very difficult for me to iterate functionality, especially because everything important was in one singular monolithic game manager script. To make it more efficient, I made that script only handle the interaction with the player, and then I split all of the underlying code into resources that could make it easier to save and share games and scenarios if I ever did decide to take this game a bit more seriously. During this day, I also discovered and fixed a lot of issues that made the game far more playable. I also worked on having a unified player system where every script would reference a specific player.type enum instead of my previous method that didn't statically type the enum. In day 6, I wanted to work on AI because no board game is complete without it, at least in the year 2025. For today's video, to allow this application to run on the widest variety of devices, we are going to be using the Minimax algorithm. Usually, inside of Backgammon, we usually use the expect minimax algorithm, which is specifically designed for games with elements of skill and luck combined. Like how in Backgammon, there is a certain amount of skill, but also a lot of luck depending on which dice rolls you get. However, the expect minimax algorithm is also substantially more resource intensive than regular minimax, which is why I am going to be doing a technique that I dub cheat minimax for games that have both elements of skill and luck. By specifically pre-generating the elements of luck that are going to be used, and by doing minimax for the rest of it, we can achieve a fully functioning AI player for a board game like Backgammon. Also, just as a reminder, if you want an explainer on how Minimax algorithm works, I would suggest that you watch Sebastian Leg's video on it and alpha beta pruning. That helped me quite a lot in this very video. There will be a link in the description below. Now, given the premise of how my AI algorithm is going to work, you would think that Cheat Minimax would be super easy to implement, and usually it would be. But Godot has some oddities that make it substantially harder to implement something like this. Mainly, in my situation here, it's the fact that resources in lists don't duplicate. They stay static. So even if I were to say to a specific resource to duplicate, if that resource contains a list of other resources, those won't be duplicated as well, which means editing those resources within the list would also edit the base class and all of that, which sucks and makes my job substantially harder, especially considering that resources inside of lists is how I store the positions of my pieces and die rolls and the spikes data in general. So I had to pre-convert all of that data into a dynamically typed 2D array that is way more prone to error because it's not statically typed. I could easily mistype one number and something could go horribly wrong, like me having the position of a triangle be used instead of the amount of pieces inside triangle, which never happened. I promise you, it's just a random example I came up with no relevance to today's story. Not only did this one issue cost me a couple hours of useful and vital time on the second to last day of this challenge, but it also cost me a couple hours of just seeing data mutate randomly without a plausible reason why. So thanks Godot, a heads up would be nice next time. Finally, we reached the last day of the week, where I mainly spent my time polishing the game and finishing my Minimax algorithm before finally making the start and game over screens, which forced me to finally realize which game modes I wanted in this game. Mainly player versus player, player versus AI, and lastly AI versus AI. For those of us who like to see the computers destroy themselves in a luck-based game, the challenge had finally been completed. If any of you want to see me try more challenges in the future, leave some challenge descriptions in the description below and I'll get back to them sometime, maybe, eventually, who knows, hopefully. Anyways, we'll see. For now, enjoy this gameplay of me playing against my own AI and winning or losing. I'm not too sure. I guess you're gonna have to figure out all on your own by watching the entire gameplay. Okay, time to play this game. Finally. So I am no backgammon professional or anything, but I'm really hoping that my Minimax algorithm is not better than me, because that would be kind of embarrassing if I lost. Anyways, let's play. Okay, I'm gonna have a very basic start, actually. Let's do something like that. Or let's do that. Okay, black is moving forward, but he's a bit exposed. These are one of his highest points position. So I could derail his plans if I went for something like that. That also puts me in a bit of a tough place. Yeah, but I don't think there's anything better for me in particular. So let's do that. Black here is gonna want to overtake that. But that's a really dumb move because that is one of my lowest position pieces, I think. So in reality, he didn't really harm me, but I was still able to move one of his pieces to the very back here. I think right now, I'm putting a pretty decent game. Let's see. Let's move this piece forward. I need to move my lowest position piece forward a bit. Let's see. I can do that move. Just trying to move as many of these pieces forward as I can. And because of the way that the AI that I designed is designed, it's going to specifically try and move these pieces to the top positions here because it's going to provide you with the most amount of point difference, which is something I could have planned for. However, I might make it beat me, so you have to make sacrifices. Okay, I'm back in. Let's do that, and so now we're going to have a tough position. We will probably we're going to need to have one piece in a high position that is going to be unprotected, or two pieces. What I'm going to do is I'm going to do this move and hope that this guy doesn't get a 1. And he didn't get a 1, which means I'm doing great. Let's see. Gonna protect. I'm gonna do that and hope he doesn't get a 1 again. Always bet against 1. That's been my strategy from the start. Even though it seems like it's not helping me too much. So what I think I'm probably going to need to end up doing is blocking the AI from progressing. Oh, that sucks. Oh yeah, that sucks. Okay, I'm planning on blocking the AI from progressing really. Which is a bit of a tough strategy to go for. But let's see, maybe the AI is gonna get like a move that really works against him. I think there we skipped one of his turns, which is good. It's exactly the type of thing I'm going for. The more turns you can skip from the AI, the better. That's how it is. Ish. Is that really the only thing I can do? Okay, let's do that. Oof, I feel kind of bad now. He finally got a piece that landed here. If I think I'm going to run away with this game just about now. To be fair, this game is running with surprisingly few difficulties and bugs. It's kind of a first for me. Kind of happy. It seems like a genuinely polished game, and I'm kind of flabbergasted, honestly. Let's do this one, and this move shouldn't be allowed, but I'm not gonna complain, am I? Yeah, I think at this point I basically just won the game. So I'm pretty happy about that. I need to fix that bug. Or I would fix that bug if I cared more about this game. However, I spent a good week on this, so no point worrying about fixing small issues like those now. I just pray that the other people play my game play it more respectively. Because you can play it the correct way, it's just I choose not to. Again, it's a robot, it has no feelings, so whatever, in it. Ish, I'm gonna win this game before you even put one in the store. Oh yeah, there we go, we won one. Absolutely terrific. What can I say? I am truly just a prodigy in backgammon. No one can beat me.